Hello everyone, in this video we will learn about the homogeneous linear equations and their solutions by using matrices. What are homogeneous linear equations? Any system of linear equations in any number of variables. If we have such that the constant terms in each equation is 0, it means the matrix B is a zero matrix. Then we say it is a system of homogeneous linear equations. For example, suppose we have a1x plus b1y plus c1z equal to 0, a2x plus b2y plus c2z equal to 0, a3x plus b3y plus c3z equal to 0. This is a system of homogeneous linear equations in three variables. Here A is the matrix of coefficients, as we know, that is A1, A2, A3, B1, B2, B3, C1, C2, C3. X is the column matrix of variables, that is X, Y, Z. But B, the matrix of constants, that is 0, 0, 0. It means we are finding this is a zero matrix. In that case, when we try to find out the solution, we know that there are two cases. Either A is singular matrix, it means the determinant A is 0, or A is non-singular matrix, it means the value of determinant of A is not equal to 0. Then what are the solution in such case? The first case is when we say determinant A is not equal to 0. It means A is non-singular matrix. Then we know A inverse exists. A inverse exists. And in such case, what we were doing? We were finding that X is equal to A inverse into B. But since B is a zero matrix, can we say this will give us A inverse into 0, that is 0? It means what? We will always get X, Y, Z as 0, 0, 0. And hence the solution will be X equal to Y equal to Z equal to 0. So we are not to find out A inverse in such cases. We can directly write that the solution of this system of equations is X equal to Y equal to Z equal to 0. And this solution is known as trivial solution. Or we call it a zero solution because the value of all the variables are 0. The second case, if determinant A is equal to 0, it means A is singular matrix. Then we say A inverse does not exist. And in this case, we were finding adjoint A into B. But since B is 0, here we will get adjoint A into B will be always 0. And if it is 0, then what we say? That the system of equations is consistent with infinitely many solutions. It means the system is consistent with infinitely many solutions. So in case of homogeneous linear equations, we have to just see whether determinant A is non-zero or determinant is 0. It means A is non-singular or it is singular matrix. If A is non-singular, then there will be a trivial solution. It means the value of every variable will be 0. And if it is singular, then there will be infinitely many solutions and the system is consistent. It means in both the cases the system will be consistent there will be no case of inconsistency in homogeneous linear equations. The concept will be more clear if we go with some examples. And the first example we are taking here is a system of homogeneous linear equations in two variables. The equations are 2x plus 3y equal to 0 and 3x plus 4y equal to 0. The matrix of coefficients will be here in this case A, that is 2, 3, coefficients of x. Coefficients of y in the second column 3, 4. X we know is x, y, the variables, and b is 0. This is a system of homogeneous linear equations. We can write this is a system of homogeneous linear equations. We find the value of determinant A. Determinant A here is 2, 3, 3, 4. This comes as 2 into 4 minus 3 into 3, that is 8 minus 9 minus 1. And this minus 1 is not equal to 0. It means A is a non-singular matrix. And if it is a non-singular matrix, then there will be a trivial solution. The system has trivial solution, and that is x equal to y equal to 0. This is the answer. The next example we are taking for three variables. Here also we find that the constant terms are 0 in each. Here for these equations, x plus y plus z equal to 0, 2x plus y minus z equal to 0, and x minus 2y plus 3z equal to 0, the coefficient matrix A is 1, 2, 1, the coefficients of x. Coefficients of y, 1, 1, minus 2. Coefficients of z, 1, minus 1 and 3. X, the matrix of variables, that is x, y, z. And b here also we are finding 0. It means we can say that this is a system of homogeneous linear equations. This is a system of homogeneous linear equations. Then what is determinant A? Determinant A here is 1, 2, 1, 1, 1 minus 2, 1 minus 1, 3. Finding the value, we expand it along row 1, and here it comes as 3 minus 2. Minus 1 into 6 plus 1. Plus 1 into minus 4 minus 1, which gives us 1 minus 7 minus 5, which is minus 11, not equal to 0. And if it is not equal to 0, then A is non-singular matrix. And if it is non-singular matrix, then the system has trivial solution. This implies the system has trivial solution, and that is x equal to y equal to z equal to 0. We discuss one more problem on the homogeneous linear equations, and the equations here are x minus 3y minus 8z equal to 0 is the first equation. 3x plus y minus 4z equal to 0 is the second equation, and 2x plus 5y plus 6z equal to 0 is the third equation. The coefficient matrix A is the coefficients of x in the first column, that is 1, 3 and 2. Coefficients of y minus 3, 1, 5 in the second column, and minus 8, minus 4, 6 the coefficients of z in the third column. X is the column matrix of variables, that is x, y and z. And the matrix B is a zero matrix, since every equation has the constant term as 0. So we can say that this is a system of homogeneous linear equations. And if it is a system of homogeneous linear equations, then we are to find out the value of determinant A first. So we find the value of determinant A. Here it is 1, 3, 2, minus 3, 1, 5, minus 8, minus 4, 6. This is equal to, if we expand it along row 1, it is 1 into 6 plus 20, minus 3 into 18 plus 8, plus minus 8 into 15 minus 2, which is equal to 26 plus 3 into 26 minus 8 into 13. Simplifying, we get 26 into 3, 78 minus 104. It is 104 minus 104, it is equal to 0. And if the value of determinant is 0, we say that it will have infinitely many solutions and it is a consistent system. This is consistent with infinitely many solutions. And to get the infinite many solutions, what we do? We take z as k, an arbitrary constant. So we write let z is equal to k. Then equation number 1 will give us x minus 3y minus 8k equal to 0. It means x minus 3y equal to 8k. This becomes equation number 4. Equation number 2, we are getting 3x plus y minus 4k equal to 0. It means 3x plus y is equal to 4k. This is fifth equation. Equation number 3 will give us 2x plus 5y plus 6k equal to 0. It means 2x plus 5y equal to minus 6k. This is sixth equation. And now we have to solve them for the values of x and y in terms of k. By solving them, we will get x is equal to 2k and y is equal to minus 2k. And we can say therefore x is equal to 2k, y equal to minus 2k, z is equal to k is the answer to this problem. And there are infinitely many solutions because k is an arbitrary constant. When we change the value of k, corresponding values of x and y we will obtain. In the next video, we will learn about the Cramer's rule to find out the solution of linear equations. Thanks for watching my video. If you have any comments or doubts, leave them in the comment box and I will get back to you.